Now, what is a chemical bond? A chemical bond is a mutual electrical attraction between the nuclei and valence electrons of different atoms that holds the atoms together. Now, since this chapter is on bonding, I am going to expect you to know the definition of a chemical bond, but you can't memorize this one. It has too many words. So really, a good working definition for a chemical bond is that it is a force that holds atoms together. Whether that be an attraction between positive and negative, or whether they end up sharing electrons. That is a force that holds atoms together that makes them more stable. All right. So let's talk about the types of chemical bonds. I expect that you probably had some of these different types of chemical bonds in other science classes, or at least briefly talked about them. And that's all we're going to do here today in this lesson. It's just briefly talk about them, and then we'll go more in depth later on next week. So, types of chemical bonding. The first type is ionic. You should recognize the word ion there, and that's really what's happening in ionic bonding. You have an electrical attraction between large numbers of cations and anions. It involves the gaining or losing of electrons. My classic example is NaCl, which is sodium chloride or table salt. That's what you have on your table at home. It is a very good example of ionic bonding. What happens is you've got sodium. It's in group 1, so it has one little valence electron. That valence electron is loosely held there by sodium. It has pretty low ionization energy. And it comes around to chlorine, which has 7 valence electrons. Well, chlorine, we know from our trends in last week that chlorine has a high attraction for electrons, high electronegativity. And so what happens when these two atoms get around each other is that chlorine pulls on the electron that sodium has and actually ends up plucking that electron off. And so what we end up is sodium losing an electron, developing that positive charge, chlorine gaining an electron, now it has 8. Sodium's also happy because it has 8 underneath, and it develops that negative charge, and it is the attraction between that positive and that negative that holds sodium chloride together. Now, it's not just one sodium and one chlorine. It is large numbers of cations and anions. So it's sodium attracted to multiple chlorines and chlorine attracted to multiple sodiums. And that kind of distinguishes it from the other types of bonding as well. All right, our next type of bonding is cooperative covalent. Covalent bonding results from the sharing of electron pairs between two atoms. So if they don't have enough strength to pull an electron off, they'll end up sharing those electrons. Now, if you have siblings, you know there are different ways of sharing. There's a sharing that happens and when your parents are around and you spend equal amounts of time with the particular toy. And then there's the sharing that goes on when your parents are not looking, and it usually involves the taller one holding the toy away from the younger one, and it spends more time with one sibling than the other. The same thing happens with electrons. Electrons can be shared equally or unequally. If it is unequally shared, we call it polar covalent. You have an uneven distribution of charge, and the bonding electrons are shared unequally. Your classic example is water. I need for you to go ahead and associate water is polar, polar, water. And later on when I ask and start talking about polar things, you will say like water, and I'll say yes, because water is polar. So what happens with water, we've got 2 hydrogens bonded to an oxygen. So I'm going to do some drawings here. You're going to be able to draw these here in about a week. So now it's just about exposure. So I've got oxygen. It's in group 16, so it has 6 valence electrons. Then we have 2 hydrogens. Each hydrogen has 1 valence electron. And they end up sharing these electrons right here. Each hydrogen has access to 2, and each oxygen has access to 8. 1, 2, 3, 4, 5, 6, 7, 8. And that makes it a nice, happy, stable molecule. If you look at where oxygen is located on the periodic table, it's right there beside fluorine. Fluorine is the most electronegative element. Well, oxygen's pretty electronegative itself, and so it pulls on the electrons from hydrogen, but it's not enough to actually pull the electron off. So they end up sharing, but they're going to share unequally. And the electrons spend more time with oxygen than they do with hydrogen. Because it has more electrons spending time with it, it develops a slight negative charge. Here's the symbol for slight. It's a weird one, so slight negative. And because the electrons are being pulled away from hydrogen, it develops a slight positive charge on each end there. We call this polar because now the water molecule has two ends, oppositely charged. It has a slight negative end and it has a slight positive end, just like the poles of a magnet, a north pole and a south pole. That's what we have here, and that's why we call it polar. We also have, so that's where the electrons are shared unequally. If they're shared equally, it is called nonpolar covalent. You have an even distribution of charge, and the bonding electrons are shared equally. Our classic example is chlorine gas. This is also known as mustard gas from World War I. What happens with chlorine gas is I've got one chlorine, which has 7 valence electrons, and another chlorine bonded to another chlorine that has 7 valence electrons. They end up sharing these, and each of them end up with access to 8. Well, this chlorine is pulling on the electrons this way, and this chlorine's pulling on the electrons this way. But they are pulling with the exact same force because they are the exact same element. And so no one wins this tug of war, so they end up sharing those electrons equally. So usually nonpolar covalent bonds exist when two identical atoms are bonded together. All right, so we have ionic, which is gaining or losing electron, and it's that positive attracted to that negative. Then we have covalent, where they're going to share. They can share unequally, and that's polar, where they have the opposite charges. Or they could share equally, and that is called nonpolar, and there are no charges in nonpolar. The last one is called metallic bonding, and it results from the attraction between metal atoms and the surrounding sea of electrons. That is a strange phrase, but it is one of the key phrases for metallic bonding, and it's not one that I made up. What happens with metallic bonding, it's kind of like a potluck dinner. Everybody brings a dish to a potluck dinner, and then when it comes time to eat, you can eat from or take some from every single dish that was brought to the table. Same thing happens with metallic bonding. Each metal donates its valence electrons, and then the atoms aren't attached to each other, they're just attached to this mass or sea of electrons. And so our example here, copper metal, it's made up of a whole bunch of copper atoms bonded together, and so we just represent it with the same symbol from copper.